In this lesson, we will examine the high-pressure pneumatic systems that are used instead of hydraulic systems on some aircraft types. These systems are not generally used on modern transport aircraft, as large components such as landing gear are operated more efficiently by hydraulic power. However, these systems are still in use on some older aircraft, such as the Fokker F-27. Compressed air has some advantages over hydraulic systems. Air is universally available and it is free. The system is lighter because the air can be dumped overboard after use, so no return lines are required, and air is lighter than hydraulic fluid. There is no fire hazard, nor is air toxic. There are no viscosity problems with changes of temperature. The major disadvantage of air is that air is extremely compressible. The diagram shown depicts the high-pressure, closed-center system used on the Fokker F-27. The two four-stage compressors are driven from the accessory gearboxes of the turboprop engines. The unloading valve ensures that the system pressure is maintained at 3,300 psi by dumping excess air overboard. A shuttle valve enables the system to be charged or operated from an external source. Two components provide protection against the possibility of water freezing in the system: a moisture separator, which removes 98% of the water present in the air, and a dryer, which removes the remaining water using a desiccant such as silica gel or anhydrous aluminium silicate. There are a number of non-return valves in the system to prevent reverse flow of the air. Filters ensure that the air is clean before it enters the system. 3 air bottles, which serve as both reservoirs and accumulators, are provided to store the high-pressure air ready for instant use. The main system has a large capacity bottle. There are 2 smaller bottles, one for the brakes and one reserved for emergency gear lowering. Most of the components operate with a pressure of 1000 psi, so the air is passed through a reducing valve before being used by the various services. There is a manually operated isolation valve which can be closed to facilitate system servicing. That is the end of the high-pressure pneumatic system lesson. You should now know the advantages and the major disadvantage of such a system.